Today we're going to be finding square roots. Our essential question for today is how can you use what you know about exponents to find square roots? Our goals for today are to find square roots of perfect squares, evaluate expressions involving square roots, and use square roots to solve equations. So some key vocabulary we want to keep in mind is that when we multiply a number by itself, we are squaring that number. Okay, so when I'm talking about 2 squared, we're talking about raising something to that second power, using an exponent of 2. So 3 squared, we are raising it to the power of 2. When we're doing 4 squared, we're raising it to the power of 2. So the symbol for squaring a number is that exponent of 2. And remember, when we are squaring a number, or when we have something raised to an exponent of 2, we're using our base of our power as a factor 2 different times. So that's going to be 4 times by 4, which is going to give us 16. Okay. Now, to contrast that, we also have another operation which is called the square root. And it is the opposite of squaring a number. It allows us to undo the square of a number. So to do this, we're going to take the square root. Okay. Now when we're taking the square root, what we need to ask ourselves is what number multiplied by itself gives me the given number. So we have our square root symbol. We're taking the square root of 16, and we're asking ourselves what number multiplied by itself gives me 16. So here I know that 16 has a number that when multiplied against itself gives me 16, and I know that number is 4. So I can say, oh, the square root of 16 will then be 4. Now the square root is going to undo this square. They're going to cancel each other out, and so we're going to be left with 4 as our answer. Okay, so a square root is a number that when multiplied by itself equals the given number. And every positive number has a positive and a negative square root. So let's look at 16. We know that the square root of 16 is going to be 4, because we know that 4 times by 4 is going to be equal to 16. And that would be our positive square root. So our positive square root of 16 is going to be 4. But 16 also has a negative square root. That's because negative 4 times by negative 4 is also equal to positive 16. So our negative square root would be negative 4. Okay. Now, when we're talking about squares, we have this thing called a perfect square, and those are special numbers that we have. Some of the special numbers that we have is 1 and 4 and 9 and 16 and 25 and 36. And the reason that they are special is that they have integer square roots. So if I want to take the square root of 1, I need to ask myself what number times by itself is equal to 1. Well, I know that 1 times by 1 is equal to 1. So I know the square root of 1 is just going to be 1. Okay, and then I can do the same thing with 4. If I want to take the square root of 4, well, what number times by itself is going to give me 4? Well, I know that's 2 times by 2, so my square root of 4 is 2. So I have these integer square roots, which makes these numbers here, 1, 4, 9, 16, 25, 36, 49, perfect squares. Now, to contrast that, all of the numbers in between 1 and 4, 2, 3, and all the numbers between 4 and 9, 5, 6, 7, 8, are not perfect squares, and so on and so forth, okay? What that means is their square roots, so the square root of 2, is not going to be some integer whole number, okay? There's no integer whole number that multiplied by itself is going to give me 2. So 2 is not a perfect square. So now we have our symbol, which is our radical sign. It's kind of like our division house, but it's got that little check out here in the front. Okay, it is called the radical sign, and it's used to represent the square root. So we're going to take the square root of whatever is on the inside of this radical sign. Now the number that goes into that radical sign, whatever we put in there, is called the radicand. So if I put a 16 into that square root symbol, that means that my 16 is that radicand. Okay. Now, we as mathematicians have come up with a system to help us understand one another, because not all the time do we need to find both the positive and the negative square roots of things. So most of the time we're going to be finding just the positive square roots, and so because we don't like to do any more than we have to, that means we're just going to see the regular radical sign. So we're going to see the regular radical sign with our radicand inside, and we just want to know our positive square roots. That's just going to be our positive 4. When we want to know our negative sign, that means we're going to special it out, and we're going to put our little negative out in front of that radical sign, which means this negative is telling us, hey, you know that square root of 16? Well, I don't care so much about that positive right now. What I want right now is that negative square root, so I'm going to put in negative 4. But in those special cases where we do, in fact, want to know both of our square roots, we have this sign right here, which is this plus and minus. So plus and minus, the square root sign tells us I want to know both the positive and the negative of this square root. So I'm taking the positive and the negative of the square root of 16, which means I want to know both the positive and negative square root, which is positive negative 4. And we can just write that as 4 comma negative 4, or 4 and negative 4. So if we want to find the square roots of perfect squares, okay, and we want to find the two square roots of this, so I need to ask myself, what two numbers, when multiplied together, give me 49? Now it can't just be any two numbers, it has to be the equal amount, so we have to say a 7 times by a 7 is going to give me 49, so one of my square roots is going to be 7. Now, generally speaking, that also means then that a negative 7 and a negative 7 will also multiply together to give me 49, so my other square root would be negative 7. As I come over here and look at 64, and ask myself what number multiplied by itself is going to give me 64, and I know that 8 times by 8 is going to give me 64, so I know that one of my square roots is going to be 8, and my other square root is going to be negative 8. Okay, and this is where we need to start looking at our radical sign, whether or not we're looking for our positive square root, our negative square root, or both square roots. So if we want to find each square root, we can look at this. We can see the radical 25 just means they want the positive one. So what times itself is equal to 25? Well, that's going to be 5. So the positive square root of 25 is just 5. Now over here we see that we have the negative square root of 9 over 16. So as we do this, we can say, oh, well, 9 is a perfect square, and we can say that 16 is a perfect square. So as I evaluate this out, what I can actually rewrite this as is negative square root over square root, and that's going to be 9 over 16. And now I can evaluate both of these right here, and that's going to give me negative 3 over 4. So my answer in this case for the negative square root of 9 over 16 is going to be negative 3 over 4. We just need to remember in our fractions that this radical sign goes both to the numerator and to the denominator. It goes to everything in there. Okay, so we're going to find the square roots here. So now we see that we have the positive and the negative of the square root of 2.25. So if I know my perfect squares, then I know that 15 times by 15 is equal to 225. Then I can say, okay, now I know that 1.5 times by 1.5 is going to give me 2.25, because I'm going to come 1, 2 decimal places in, 1, 2 decimal places in. So I know my square root here is going to be positive and negative 1.5, or positive 1.5 and negative 1.5. Now as I come over here and I look at this right here, we can see negative square root of 81. As we're looking at the negative square root of 81, we know the square root of 81 is just going to be 9, because 9 times by 9 is going to give me 81. So negative 9 is going to be the negative square root of 81. So continuing on here, we see that we have plus and minus the square root of 9 over 64. So as we look at this, we know that we can rewrite this as plus or minus the square root of 9 over the square root of 64, which means that we are going to be looking for 3 over 8 and negative 3 over 8 for our answer. Okay. Now as we look at this next one right here, we're looking at the square root of 4.84. So if we do 22 times by 22, what we're going to have is 4 and 4 and 0 and 4 and 4. So we end up at 484 for 22 times 22, which means that the square root of 4.84 is just going to be 2.2, which will allow that to come in 2 decimal places. So I know that my square root of 4.84 is just going to be 2.2. So go ahead and try these on your own real fast, and once you are done with that, go ahead and resume the video to see if your answers match up with mine and if your understanding is where it should be. So as we look at this, we're going to be finding the 2 square roots of the number. As we look at this, we want to know what 2 square roots we can get from 36. So we're looking for both the positive and the negative square root of 36. Since we're looking for both positive and negative square root 36, we know that 6 times by 6 is going to be 36. So we're looking at positive 6 and negative 6. For problem number 2, we have 100, and we're going to try and find the positive and the negative square root of 100 because we're looking for the 2 square roots of this. So we know 10 times 10 is 100, so my answer is going to be 10 and negative 10. For problem number 3 here, we see that we have the square root of 121, or positive and negative square root of 121, because again we're looking for those 2 square roots. So that's going to be 11 and negative 11. As we look at problem number 4, we have negative square root of 1, and as we are evaluating this, we are just looking for the negative square root, so that's just going to be equal to negative 1. As we look at this next one right here, we have plus and minus the square root of 4 over 25. Since 4 and 25 are both perfect squares, we can just rewrite this as plus or minus the square root of 4 over the square root of 25. And by doing that, we can see that this is going to be equal to plus or minus 2 over 5, or positive 2 over 5 and negative 2 over 5. Now, as we look at this last one right here, we're looking for the square root of 1,225. So I don't have that one off the top of my head, but if we do the second square root of 2.25, we can plug that into our calculator and see that that is going to be 3.5. So we're going to be 3.5, because 3.5 times 3.5 will give us 12.25. So as we begin evaluating expressions involving square roots, what we want to do is understand where this square root happens in order of PEMDAS. So when we're thinking of PEMDAS, we have our parentheses, exponents, multiplication, division, addition, and subtraction. And because our square root proceedings happen so interchangeably with exponents, it works just like how division undoes multiplication, how subtraction undoes addition, how those are related to each other. Our square roots are also inside this exponent right here, so they come right with those exponents. So that's when we want to also evaluate our square roots, which means we need to do those first right after parentheses. Now the next thing we need to know is when we have a number right in front of our radical sign, what we actually have right here is a little multiplication symbol in there telling us, hey, we're taking this 5 and we're going to times it by that square root of 36. So as we do this, we're going to first evaluate the square root of 36, and because we don't have a positive negative sign in front of that, we're just looking for the positive one. So what we're going to see is 5 times by the square root of 36, which we know is 6, plus 7. So 5 times by 6 is going to give us 30, plus 7 is going to give us 37. Then as we look at this next one over here, we have 1/4 plus the square root of 18 over 2. Well, 18 is not a perfect square, and 2 is not a perfect square, so we don't want to move our square root symbol out and to take the square root of 18 and the square root of 2. Instead, what we can see is that we can take this fraction that appears inside of this radical sign and simplify it. So we do 18 divided by 2. When we do 18 divided by 2, what we're actually going to end up with is 1/4 plus the square root of 9. When we have the square root of 9, then we know, hey, that's just going to be 3. So we're going to say 1/4 plus 3, which is going to be 3 1/4. Now, if we want to rewrite this into an improper fraction, we're going to end up with 13/4. So continuing with some of these evaluations, what we can see is we are looking at the square root of 81 squared minus 5. And as we do this, we're going to take the square root of 81, which is just going to be the 9 squared minus 5. And then 9 squared is going to give me 81 minus 5, which is going to give me 76. Now, if we recognize here that our square root is undone by immediately squaring it, then we could just skip this step right here and just come right back down to here and then just do our subtraction. With this second one over here, we see that we have 2 times by the square root of 144 minus 30. So we're going to take the square root of 144, which we know is 12, so we're going to end up with 2 times by 12 minus 30, and 2 times by 12 is going to give me 24 minus 30, and 24 minus 30 is going to give me -6. So as we look at this first one, there are two main ways that we can go about doing this. The first way is to look at this and see that we have 36/4, and we can simplify this fraction inside of our radical sign. So 36 divided by 4 is 9, so we end up with the square root of 9 plus 1/6. We know that the square root of 9 is just going to give us 3 plus 1/6, and 3 plus 1/6 is just going to be 3 1/6, which we can then rewrite into an improper fraction as 19/6. Then the second way that we could look at this is we could see, oh, 36 is a perfect square and 4 is a perfect square. That is going to give me 6/2 plus 1/6. That's going to give me 3 1/6, which is going to give me 19/6. So perfectly valid ways of going about and solving that. Now, over here we see 49 minus the square root of 49 squared. So if we do this, this will be 49 minus the square root of 49 will be 7, and that'll be squared. So we'll do then 49 minus 7 squared, which is 49, which is then going to give me 0. So the other way we would see this is we are taking the square root of something and then immediately squaring that. Those two operations will cancel each other out, so it would be just as though we had not seen those two things in there, and it would just be 0. Okay, so go ahead and try these ones on your own. Once you're done trying these on your own, go ahead and resume the video to make sure that you got the same answers that I did. As we look at this, we see that we have 12 minus 3 times by the square root of 25. We need to evaluate our radical sign first, so we end up with 12 minus 3 times by 5, because the square root of 25 is 5. 3 times by 5 is going to give me 15, so I get 12 minus 15, which is going to give me -3. As I look at this second one right here, I see that 28 is not a perfect square and 7 is not a perfect square, but I can simplify 28/7, which is going to give me the square root of 4 plus 2.4. When I see the square root of 4, I know that's going to be 2 plus 2.4, which is then going to give me 4.4. Looking at this last one down here, I see that I have 15 minus the square root of 4 squared, which is going to be 15 minus square root of 4 is going to be 2 squared. 15 minus 2 squared, 2 squared is going to give me 4, so I have 15 minus 4, and 15 minus 4 is 11. Now as I look at this last example here, I'm going to find the side lengths S of the square. So what I see is I have an area, and that area is 81 yards squared. And I know something about my square. I know my side lengths are equal, which means its length and its width are the same. So I have S squared is equal to 81, because I know the length times by the width is going to give me my area, and I know that's s times by s, which I know is s squared. So if I want to just find s, what I want to do is I want to take the square root of 81. So if I do that, I'm going to end up with s is going to be equal to, s is going to be equal to 9. S is equal to 9. Okay, and here we have our mini assessment. So if you'll go ahead and attempt these problems on your own, put them in your notes and I will check for them on Friday.